Let's look at another type of example problem in section 6.2 as it relates to capacitors. Okay. Now, the problem says the voltage across the terminals of a 0.4 microfarad capacitor is given by Vc equals to 25 volts for t less than or equals to 0 and Vc equals to A1 t e to the negative 1500 t plus A2 e to the negative 1500 t volts for t greater than or equals to 0. Now, the initial current in the capacitor is 90 milliamperes. Assume positive sign convention and now find the initial energy stored in the capacitor. What are the values for the coefficients A1 and A2? Find the capacitor current at t equals to 0.4 milliseconds and at 2 milliseconds. It's actually a simple problem. I'm not going to solve it entirely, but I will get you started. Okay, the first thing you want to notice is that for A, when we are interested in calculating the energy, you remember the half kx squared, half mv squared, half li squared. For capacitance, it is half cv squared. Okay, you can go back to the summary of the capacitor and find out that it is indeed 1/2 Ci squared is the energy stored in the capacitor. Okay, and then it says initial energy. So we are interested in finding at t equals to 0. Okay, at t equals to 0, I can plug in the value for capacitance 0.4 microfarads and multiply that by V squared, which is 25 squared. Okay, because the voltage at t is equals to 0 is 25 volts. So plug that in and you will see that you'll get a neat value for the energy stored in the capacitance. Now the next part is that given Vc equals to 25 volts, t less than or equals to 0, and it's equals to A1 t e to the negative 1500 t plus A2 e to the negative 1500 t volts for t greater than or equals to 0. What is the value of A1? What is the value of A2? How do we find that? We have not seen this kind of problem in the past. Well, we basically use our understanding of mathematics in common sense manner. Think about this. For t less than or equals to 0, the initial voltage is this guy. And for t greater than or equals to 0, this guy. So in other words, for less than or equals to 0, it is 25 volts. For greater than or equals to 0, it is this guy. Okay. Therefore, when you find the value of voltage at t equals to 0, okay, both of these should be equal because one is less than or equals to, the other is greater than or equals to. So they intersect at that time. Therefore, A1 t e to the negative 1500 t plus A2 e to the negative 1500 t. When you calculate that at t equals to 0, when you substitute a value of t equals to 0, that value should equal 25 volts, right? So that's this and this are equal at t equals to 0. That's the bottom line. It's a simple idea. Okay. Now, once you do that, what you will see is when you plug in t equals to 0, this will go away. all of this term will go away, and A2 is remaining to be 25. So you found the value of A2 simply by noticing that when time t equals to 0, both these terms should be equal. Okay. Now, how do you find A1? In order to find A1, what we can do is we can look at the current at t equals to 0. What is that value given to? I at t equals to 0 is given to be 90 milliamperes, right? Somewhere in here. The initial current in the capacitance is 90 milliamperes. So this is what I'm going to do. I'll take the expression for voltage, which is equals to A1 t e to the negative 1500 t plus A2 e to the negative 1500 t. Okay. Now, if I do the derivative of this, C dV by dt, right? So if I do C dV by dt of this, which simply means I have to do that on both sides, okay? So multiply both sides by C and take a derivative of that. What is that equals to? C dV by dt equals to the current. Remember? Or let's go back to the formula. The current is C dV by dt. Okay? So based on the initial conditions given, I should be able to plug in a value of 90 milliamperes here, and then take a derivative of this, derivative of A1 t e to the negative 1500 t plus A2 e to the negative 1500 t, right, by dt of this, and equate that to 90 amperes. Okay, so and plug in a value of t equals to 0 for this. Okay, plug in a value of t equals to 0 once you take the derivative. Okay, after you take the derivative, plug in a value of t equals to 0. Okay, now let's see if we do the derivative first. I'm going to plug in t equals to 0 later on. Okay, if I do the derivative, what I should see is A1, so dV by dt is A1 e to the negative 1500 t plus A1t times negative 1500 times e to the negative 1500 t plus A2 into negative 1500 t into e to the negative 1500 t. Okay, how did I get all of that? It's straightforward. You do, this is a constant, you leave it like that. Now, t e to the 1500 t can be written using the chain rule as this guy plus all of this. Okay, so that's the chain rule. Similarly, this guy, e to the negative 1500 t is negative 1500 t multiplied by that guy. Okay, so once you do the derivative dv by dt, and you see that its value is going to be, its expression is going to be something when you plug in a value of t equals to 0. At t equals to 0, dv by dt should be a1 e to the negative 1500 t, which is a1, plus a1 into 0, So if you simplify this equation, you should get something similar to this. A1 minus 1500 A2. Okay, so this is the derivative dv by dt. But you know c times dv by dt is, what's that? I. Okay, at time t equals to 0, I has been given to be 90 milliamperes. So dv by dt is 90 milliamperes, which is this current, divided by the capacitance, how much ever value that is. The capacitance value is given to be 0.4 microfarads, okay, 0.4 microfarads. So then you should see that this guy dv by dt, which is A1 minus 1500 A2, should be 225,000 volts per second. Okay, so that would be the derivative at time t equals to 0. Okay, once you have this, remember we calculated the value of A2, which is 25. Okay, so now you should be able to calculate the value of A1 from here. You should see something around 262,500 for that. Okay, so that's B. You're supposed to find the value of A1 and A2. A2 was easy to find out. Simply do equate the time expression to the value. Okay, at time t equals to 0. For finding A2, all you have to do is to find the derivative, and then you know that the derivative multiplied by C, the derivative of voltage multiplied by C is I. The value of I is given, so dV by dt equals to I over C. And from this, you can find out the value of A2. Okay, so that's about number B. How about C problem, the part C of this problem? What's the part C of the problem? Find the capacitor current, I capacitance, find it at t equals to 0.4 milliseconds, right? That's the problem. Find the capacitance I current IC at t equals to 0.4 milliseconds. How do we go about doing that? Well, we know the expression for current voltage, right? VC equals to A1, right? VC equals to, what's the current voltage expression that's given? A1t e to the negative 1500 plus A2 e to the negative 1500. So A1t e to the negative 1500t plus A2 e to the negative 1500t. This is the expression for voltage, right? And we did find the value of A1 to be 262,500 and A2 to be 25. Now, so VC of t is really 262,500 times t e to the negative 1500 e to the negative 1500 plus 25 times t, right? 25 times e to the negative 1500 t. Okay, this is voltage. Now we are supposed to find the current, right? And you do know the value of the capacitance to be 0.4 microfarad. We did that problem already. Where did we do that? Very first problem, is it? You are given a value, an expression for V. You're given an expression for C. You're supposed to find the current. All you have to do is C dV by dt. That's exactly what we will do in this problem. Knowing the value, the expression for V, knowing the value for C, we can do I of t equals to C times dV by dt. Okay, so C is 0.4 microfarads. Multiply that by 265, 262, 500 t e to the negative 1500 plus 25 e to the negative 1500 t. All of that, you take a derivative. Okay, you do that, you find the derivative and get the expression for it. You should be seeing, now you can, I of t should look something like, I of t should look something like 90 minus 157,500 t e to the negative 1500 t, okay, in milliamperes. So in order to find I of t at t equals to zero point 0.4 milliseconds, 0.4 milliseconds, you plug in this into the t value, and then you should see a value of I of t equals to 0.4 milliseconds. Okay, so I leave those parts as an exercise to you. I still have shown you the steps that you need in order to solve what looks like a complicated problem, which it really is not a complicated problem. It's a simple problem following step by step.